Hi, I'm Xavier Espinosa. Today we're going to talk about the height of the diver when released. This is the equation, 50 sine times 9t plus 65. 50 represents the radius of the Ferris wheel. 9 is the angular speed we found. 65 represents the starting height of the diver, while t represents the time he is spinning. As you can see here in this example, the Ferris wheel has a radius of 50 feet and it's starting at 65 feet. He drops after 10 seconds. You can see we plugged in 10 into the equation where t would be. After plugging this into the calculator, you can see that we got 115 feet when the drivers dropped after 10 seconds. Thank you.
Hi, I'm Daniela, and what we'll be doing today is we'll be finding the time at which we should drop the diver for high dive recording. So I first want to point out that we're going to need to know the horizontal x-coordinate of the cart, because obviously the time we should drop the diver is going to be responsible for the time where the cart is going to be exactly. So we need to have that, and luckily we have that in our Ferris wheel info, which I got it right out of. And then we also need to have the diver's x-coordinate horizontally, because that will tell us when the diver, where he should be on the x-coordinate and where the cart should be too. So once you plug these into a graphing calculator or Desmos, you will come up with a graph like this. The red is the horizontal x-coordinate of the cart, and the green of this cosine graph is the diver's x-coordinate horizontal. When you graph these, you'll find an intersection of it being 12.283, and that will give us at the time we should drop the diver. So this time we're going to find out now the time the diver will be in the air after release. So once he jumps off of being in the wheel for 12.283 second, we're going to now use the following equation, which we got from our Ferris wheel info. So this equation will tell us if the wheel turns for w seconds, which is 12.283, before blank, the assistant lets go and the diver will fall for exactly this equation will give it for us all. So we're looking for the falling time. That's our main thing. And we plug in our radius, which is 50, which is the Ferris wheel. The angular speed is 9, and the 12.283 is when the wheel turns before the assistant lets go, which is very important, and the center height, of course. So when you plug this into a calculator, you'll get this long number of 2.54729304689. Then you're going to want to obviously round, and 7 to the 4 will make it go up a number, giving us 2.55 seconds, the time the diver will be in the air after being released.
In order to find the final location of the cart, we use the equation for the cart's horizontal distance and plugged in W. W is the seconds after the diver is released from the fear spot position. After plugging in the number, we were able to find the cart's horizontal distance. And because it's negative, we know the cart's horizontal distance is going to be on the left of the wheel and not on the right, because the right is positive.
In order to find the total time the cart needs to travel, we put together the seconds after the diver is released and the equation giving us the time the diver is falling. After plugging in how many seconds after 3 o'clock position he is released, we're able to find the total time the cart needs to travel, which is 12 seconds and 12.79 seconds.
We'll be finding the horizontal location. I use the cart's horizontal x-coordinate, and it's this really big equation right here. And then I use the 50 cosine of 9w, which is the horizontal position of the diver. So after getting these two equations separate, I plugged it into the calculator, shown like this. And then after that, I graphed it. And this is supposed to be my graph after graphing it. And after that, I used the calculator and I did second, trace, intersect, enter, and enter. And the intersection should have been x equals 12.28 seconds and y equals negative 17.55 feet. So The 12.28 seconds is how long it will take him to reach the horizontal location. So his total horizontal location is negative 17.55.